Hello and welcome back to Calculus 2 on this wonderful Thursday. So we are going to look at 8.6 integration strategies, which is technically the summary of what we have learned so far for integration. We are not learning any new methods today. This section is there to teach you how to recognize various methods, which method is appropriate to use when, and all of that good stuff. Now, the methods which we have discussed so far are basic integration from Calc1, U sub from Calc1, back substitution, also Calc1, and then you have a whole bunch of these new ones by parts, trig, substitution, trig integrals, partial fraction decomposition. All of that stuff is from Calc2. So we are not learning new methods. All we do is we are learning how to implement these methods and how to recognize which one is which. So let's go and take a look at most important thing that we have here, and that is, let me get the red one. If integral is not basic, check U sub first. U substitution is going to deal with most of the problems. So we definitely want to make sure that the problem is basic, right? And basic U sub to make sure that we can, right? If it's a basic U sub, we can solve it quickly. So here is an example of that situation. So integral of x over x squared plus 4 dx. So what should I, oh sorry, I wanted to say minus x squared minus 4. All right. So since we're talking about integration strategies, right? If you're looking at this and you say, well, this looks like a U sub, you're right, because it is a U sub, right? And you can solve it literally in 2 steps. U equals x squared minus 4, du equals 2x dx. Fix the 2 that you need, and your integral becomes 1/2 du over u, which is 1/2 ln of u, which is 1/2 ln of x squared minus 4 plus c. So something like this you should be able to do in your sleep, right? But let's say that you are in your own world and you just say, well, that's not a Calc2, right? It's a Calc1. Yeah, but you still need to know addition, which was pre-algebra. So you always check for U sub first. Now, let's say you like pain, right? and you are really defiant, what do? Well, you can clearly do partial fraction decomposition, because this integral can be factored, and now you can do partial fraction decomposition on the same problem, right? So you say integral of a over x minus 2 plus b over x plus 2 dx. You better get the same answer, right? So we are going to now do the partial fraction decomposition. That will give us x equals ax plus 2a plus bx minus 2b. So your x plus 0 is equal to a plus b times x when you factor x out, and plus 2a minus 2b. So that gives you that a plus b equals to 1, and 2a minus 2b equals to 0. From the bottom equation, you know that a is equal to b, because when you move b to the other side and you divide both sides by 2. So if a is equal to b, then they both have to be 1/2. So we have integral of 1/2 over x minus 2 plus 1/2 over x plus 2 dx, and those are your 1/2 ln of x minus 2 plus 1/2 ln of x plus 2 plus c. Now you might say, well, hold on, that doesn't look like my answer from above. Yes, it does. If you factor out 1/2 and combine ln's into a single ln, you get exactly the same answer. Factor out 1/2, you get ln of x minus 2 plus ln of x plus 2 plus c, and that condenses into a single ln of x squared minus 4 plus c. Because when you have addition of ln's, their arguments multiply. When you FOIL it, you will get x squared minus 4 because it's difference of squares. Now, the method is way longer than the basic u sub, which we were able to do in 2 lines, right? So we always supposed to choose the easiest method. But if you miss it, the problem is still possible. The problem can still be done. I'll call this way 1, way 2. Now, you really want to push it. And you say, yeah, it's all cool and fancy and fun, but can we do even more with this? Well, let's try trig sub. Why not? I mean, that's all fun. So, you know what? Let me color code these. So this way 1 is all going to be light blue. There we go. That's your way 1. We leave way 2 black, and let's go purple, I guess, for the way 3. So integral of x over x squared minus 4 dx. Set up a triangle with angle theta. We have x to be hypotenuse, and then we have a 4 and the square root of x squared, no, 2 minus 4. So we work out equations towards a number. Do I want to switch this because the tangent, yeah, I want to switch this. So 2 and the square root of x squared minus 4. So now I have the tangent function. Tangent theta is going to be square root of x squared minus 4 divided by 2, from where the square root of x squared minus 4 is equal to 2 tangent theta. And when I square both sides to lose the square root, because I don't have a square root in a problem, right? I square both sides to kill that. I just get 4 tangent squared theta. Okay. Now this equation is going to be a cosine of theta. Cosine of theta is going to be 2 over x. I need to solve this for x, which is going to be 2 over cosine, which is 2 secant theta. And I immediately need dx to replace as well. So 2 times derivative of secant is secant tangent d theta. So now we plug all of this in. I have this, I have this, and I have this. So all of these plug in. I get integral 2 secant theta divided by 4 tangent squared theta 2 secant theta tangent theta. Oh wait, no, that's dx. Oops, sorry. The denominator is 4 tangent squared theta. There we go. And then over here 2 secant theta tangent theta d theta. There we go, much better. All right, so we are going to have all of the constants cancel, because 2 times 2 is 4, kills the 4 in denominator. One of the tangents drops, and we are left with secant squared theta divided by tangent theta d theta. So this is where now trig integrals kick in. And this trig integral is what? Secant squared tangent theta. So the derivative of tangent is secant squared, so it's a u sub. U equals tangent theta, du equal secant squared theta d theta. So the whole integral becomes integral of du over u, which is ln of u plus c. I hope. Now we have to go back to theta and then eventually back to x. So u is tangent theta. And from the triangle, tangent is equal to square root. So ln of absolute square root, what was that? Square root of x tangent. Where is the tangent? Here. Tangent is right here. So square root of x squared minus 4 over 2. Yep. Plus c. So we just fix this to look like the other answers and we're good to go. So what do? The first order of business is to do this division by 2. I see the question in the chat, isn't it the second tangent? Yes, but we had 2 tangents here, and one tangent there, they canceled. So only one tangent in the denominator. Okay, so now we have ln of absolute square root of x squared minus 4 minus ln of 2 plus some constant c. This gets absorbed, makes a c. And this becomes ln of x squared minus 4 to the 1/2 plus some constant c again, because that ln2 is a number, it gets absorbed. And 1/2 jumps in front, and there is the same answer. I need these parentheses. So we have three ways to do the same problem, right? Now, obviously, u sub was something that we did very quickly, and we're done. And then when you look at all of the other ways, right, some problems can be done with multiple ways. Now, we would like to find what is the appropriate, fastest, and the easiest way to do the problem. Now, some problems can only be done one way, and that's the way you have to stick with. So, since we are doing the online instruction, in addition to what I do here on these lectures on the stream, you should be really reading all of the examples from the book and working them out on your own as you are as you are studying. So the rest of the lecture, again, we are not learning new methods. We are learning to recognize the method and to use the appropriate method to solve the problem, the fastest if there are multiple available. So now we have questions in the book on page 560, 561. We have questions 7 through 84. So pages 560 and 561, questions 7 through 84. They're just integrals. It says integrate. No directions. No one is mentioning any of the methods. You know all the methods, right? They were listed at the beginning of the lesson today, right? So some of them are in Calc 1, some of them are in Calc 2, and you get to pick the method and solve the problem, right? So it's very useful to practice this as a review for the whole course. So let's see some of the obvious problems. Problem like problem 8. It says integral cosine to 10x, cosine squared to 10x dx. What do we do here? Again, we are not solving any of these today. I'm just talking about the methods. You will try to solve every single one of these as a review, and then ask me questions during the review for a test. I will solve them in detail. So what do we have here? We obviously have power reducing plus u sub later on. The only way to integrate cosine squared is to make it into, use the power reducing to get rid of the square, and then you will have to use u sub for the 10x if you don't know the shortcut formula to deal with that. So that will be labeled as obvious problem. Another obvious problem is problem 16. dx over x to the 4 minus 1. Why is this obvious? Oh my god. Hold on, I was trying to reply to the message and it just kicked me. And yes, there's plus c. So the next problem here, problem 16, is also very basic. Actually, what I should do now is I should just pause if anyone wants to. So I'll pause for about 40 seconds. I think 30 seconds is the stream delay. So about 40 seconds to say if you would like to suggest in the chat which method I should use for problem 16. Again, this is labeled as obvious problem. Anyone? dx over is the stream working? Okay, it's working. So we are using partial fraction in here. Factor plus partial fraction. So, next problem. Ooh, this is evil. W cubed e to the w squared dw. Calculus. They would put something like this on the... So, number 17. if cube and square were flipped, it would be a joke of a problem, right? It would be basic U sub. So if we had w squared e to the w cubed dw, that one would be basic U sub, right? And you're done. But that's not what we have up there. We have these powers flipped. So it's not basic, it's not U sub. We have to figure out what to do, right? And for this one, we can try U sub and see where it takes us. I'm going to say U equals W squared, du equals 2W dW. I don't have a 2, so I'll put that in and see where I get. Now, see, most of these problems you just have to try. So where does it go? It goes to now, you see, if I split this w cubed into w and w squared, I can use 2w for du. So this becomes u e to the u du. So there are two w squared over there. There is a w in here, and this is my w squared. So they're all accounted for. It's a little bit hard to see these kind of things, but once you see it, you're done. And now this one is basic. So we have a u sub plus by parts. Once you convert it, this thing over here is going to be by parts. So it's a lot of practice, right? It's a lot of practice to get these things done. Let's see. There is a standard problem. X minus 5 to the 10 dx. That's a back substitution. That one should be too. That one should be simple. (21) x to the 9 ln 3x dx. We did this in class. That's the by parts. All right, this one looks difficult. Dx divided by x open parenthesis ln squared x plus 2 ln x plus 2. What do you think about 26? All right, so I'm hearing partial fraction decomposition. Well, we have to start with u sub, right? And then we'll see what it leads into. Because we do have 1 over x as a u sub for ln x, right? So we start with u equal ln x, du equals 1 over x dx. And once we convert the problem, we can decide what's the next step. So 1 over x dx over here becomes du, and denominator becomes u squared plus 2u plus 2. So we are starting problem by using a u sub. Now, we cannot factor denominator. And because we cannot factor denominator, that means we only have one factor, and that would not be enough for a U sub. For partial fraction decomposition. We only have one of these, right? So, and I need minimum two factors, right? So we cannot use partial fraction decomposition from this point on. We cannot use another U sub because we don't have 2u plus 2 on the top in the numerator. So what should we do now? This should be $1 million question. This one is tricky now. Let's see if anyone figures it out. Any suggestions? Come on, think about it. Yes, Rory! Nice, man. Yes, good, Mark. Yep. Complete the square, and we are going, with the completed square, we are going into what? So, if we complete the square, what is the... So, once we complete the square, the next step is... Then your favorite trig sub, right? Then you go and you do the trig sub afterwards. So you start with the U sub. That gives you the problem in blue. Then you complete the square to do the trig sub. Are all good. So once you do the completing the square, you will be in the form to do the trigonometric substitution. If you forgot completing the square, you take half of b and you square it and you add and subtract. So it would be u squared plus 2u plus 1 minus 1, and then you have plus 2. So these three would give you u plus 1 squared plus 1, and it's a trig sub. Integral du over u plus 1 squared plus 1. That's a trig sub question, because you can draw the triangle. You have u plus 1 on one leg and a 1, and a square root of u plus 1 squared plus 1 over here. Obviously, you will be squaring both sides later to kill the roots, so you can substitute. So yeah, these problems tend to be really, really interesting, right? Maybe our definitions of interesting are not lining up, but I mean, it's fun. You like trig, right? So we should skip right into trig, because a couple of these problems are really obvious, like 30, 31, 32. They're all straight out of book trig subs. Couple of u sub, but then starting 34, we have a whole bunch of trig questions, and this is a very, well, 30. Let's go with the 34 because that one is obvious and easy. You just have to be careful with constants. This one is obviously just a basic U sub. This one should literally take you, less than a minute to plow through it. You have the cosine 3x plus 1 as a u, and you just du is already ready up there. You just have to worry about a constant of a 3 and 1/3 in front of the integral, and you're done. So it should be 2 lines. Way more interesting, problem 40. Integral of sine 2x times ln of sine x dx. So this is way more interesting than the previous problem. So think about this one a little bit. Integration by parts. Can we use integration by parts here? We have to integrate. I'm intrigued. Actually, I want to try. That's not what I had in mind, but I want to try. Maybe we can use integration by parts. Let me see. We set u to be ln and dv to be sine 2x dx because life, right? Then du would be cosine x negative derivative of sine is cosine positive cosine sine x dx, and the v would be integral of this. Integral of sine is negative cosine, so negative 1/2 cosine 2x cosine 2x. So that would work out to be negative 1/2 cosine 2x times ln sine x minus, and minus is a plus, 1/2 integral cosine 2x times cosine x over sine x dx. The cosine over here can be written as cosine squared minus sine squared. It's making it messy. Cosine squared x minus sine squared x times another cosine x divided by sine x. Oh, it can be done now, because this sine x actually can be also written as 1 minus cosine, so this could be written as a 2 cosine x minus 1, and that becomes 2 cosine squared x minus cosine x over sine x, and then you split it and use basic u subs. Yes, it can be done by integration by parts. Wow, it's a lot of mess, but apparently it can be done. Okay, very good. I'm not sure if you went through all of this mess to get to that conclusion, or if it was a stab in the dark, but apparently it can be done. Nice. This is a good question for a lab, I guess. What I should just say, you must use integration by parts, and then technically, good luck to you. I had something else in mind, so I'm going to get rid of this stuff. You can rewind the video if you really want to go through the pain of by parts here. I am very impressed that this worked, actually, so I'm happy. What I want to do is just use the basic trig identity. So I'm going to write this as 2 sine x cosine x, and then the rest is ln sine x dx. And the problem is technically done now, because you have your u equal sine x and du equal cosine x dx. There is the cosine there. So that introduced the cosine for a basic u sub. Kick 2 outside. This sine becomes u. Cosine dx is going to be our du. So there we go. And now it's just a basic by parts. So it was trig identity that helps us use basic u sub, and now we can do by parts to deal with the ul and u. You might have memorized that part, I don't know, but it's still possible. All right. What else terrible can we get over here? I mean, they're all terrible. Oldest trick in a book. Two x cubed plus x squared minus 2x minus 4 divided by x squared minus x minus 2 dx. Oh, you better know what to do with this one, because you knew what to do with it 2 days ago. Yes, Mark. Yes, Cassie. Great, great. Long division, partial fraction. Excellent. Excellent. I'm just going to put this here and move on. There goes couple of hours of work. Sine 2x times e to the sine squared x dx. And then we'll just go and look for another problem. use two identities. What do you mean you use two identities? Are you talking about 47 or 56? Okay, we can start with identity and then U sub. So technically it should be the same as I believe problem 40. Yeah. So hopefully we can start with 2 sine x cosine x, and then we have e to the sine x, right? That's all squared dx. So we immediately start with the u sub. Make this sine x, and du becomes cosine x dx. So this might take care of the problem. Remember, you have to change the limits, so we'll get there. 2 gets kicked outside. Sine becomes u. Cosine along with dx becomes du. And yep. So another u sub. I mean, call it v sub or something. Another u sub. And sine of pi is 0. And sine of 3 pi over 2 is negative 1. And then you use another u sub. Well, use another different variable. That was 56. It looked terrible. Next time when you want to shush someone, just write this and say here. Have fun. I like problems 66 and 67, the way they are next to each other. X over square root of 1 minus 9x squared dx, square root of x squared over square root of 1 minus 9x squared dx. The suggestion is to use a trig sub. And the answer is you can use trig sub on both. Or any other suggestions? Yes, nice. U sub for 66, trig sub for 67. Now, trig sub will also work for 66 as well. We started the day with this kind of discussion, right? So I'll write it in blood. U sub, but also trig sub, and the other one is trig sub. Cool. Sometimes it's cool kind of to pick up a problem I have no clue what to do with, and then let's figure it out. Integral 1 minus cosine x 1 plus cosine x. I have no clue what to do here. Multiply by 1 minus cosine. Let's see. So if I multiply times 1 minus cosine x times 1 minus cosine, will this work? I'm thinking out loud. So that will be 1 minus cosine x squared divided by 1 minus cosine squared x dx. And that's a sine squared there. Aha! Okay, got it. So 1 minus 2 cosine x plus cosine squared x divided by sine squared x dx. And now you split into 3 integrals. Yeah, so you can only change sines and cosines when you have a squares through Pythagorean identity. You can't change the single power, right? So now we have 3 integrals. You have 1 over sine squared. Well, that's a cosecant squared. That's a basic integral. Then you have 2 cosine x over sine squared x. That's going to be a cotangent cosecant integral, which is also basic. And you have cosine squared over sine squared, which would be cotangent squared. That one you would have to, work a little bit, probably you by parts or something. And cool. Um, 72 is also obvious. You did not have a lot of practice with this stuff, but you have this is by parts. I mean, you are mixing 2 functions that are not of the same type. You're mixing polynomial function with sine hyperbolic, right? So integration by parts is designed to deal with these functions that are not compatible with each other, right? And let's take a look at 75, and we'll call it here. Now, as you can see, I haven't solved a single one of these. So I'm hoping that you will go through all of them, practicing for the for exam, and ask questions if you can't solve any of these. Either shoot the email or ask questions during the review session. Now we still have 3 sections to cover before, five. We still have chapter 9, 2 sections, and we have 3 sections in chapter 8. So we have 5 sections to go. So there's no way having exam in the next 2 weeks. But you should start preparing now, especially that you have to study more on your own. Okay, 75, integral 1 to 3. Tangent inverse of a square root of x divided by x to 1/2 plus x to the 3/2 dx. It looks terrifying, right? But as soon as you realize that square root of x is x to the 1/2, you can just factor out square root of x, and then you should be able to see basic u sub. So integral 1 to 3, tangent inverse of root x, and in denominator you factor out root x, and you have 1 plus x dx. You start with a u sub, where u is root x, to at least get the root x out. Du is 1 over 2 root x dx. Well, I don't have a 2, so we'll put 2's in. And I have 2 integral 1 to root 3, and I have tangent inverse of u divided by 1 plus u squared du. Because, let me see if I got all of these. 2 dx, that's all of this. Tangent inverse of root u, and then 1 plus x is u squared. Yep, got them all. Got them all. And we also switched the limits, right? Square root of 1 is 1, and square root of 3 is root 3. And this is our new integral. And now we are supposed to figure out what to do with this thing. Any suggestions? There is one technique that, out of all techniques that we learned, only one of them is an expert in getting rid of things we don't like. Which technique is that? Anyone? Nope, it's not. Doesn't have to do with trig. It should be by parts, right? So try by parts. U equals tangent inverse x, and dv equals 1 over 1 plus u squared du. Well, I can't use I can't use u and v because I already have u in a problem. Let's use g and v. So now dg would be the derivative of inverse, which is 1 over 1 plus u squared du, and the integral over here would be tangent inverse of u. Now you're going to say, hold on, we did not achieve anything. Yeah, we had the problems like that when you don't achieve anything for 2 steps and then you figure out that you did achieve something eventually. So try integration by parts on this and see how it goes. So that's 8.6. 8.7 is other methods of integration, and that one is using the chart. At the end of the textbook, there is a chart with 106 integrals. I think it's called integration tables. So all the way at the end of the book it says table of integrals. So 8.7 other methods. I'm just gonna say number 1, use software, and number 2, use table of integrals, back of the book. I really don't spend any time on this because you should be able to punch in the problem into computer to see what the integral is equal to, and you should be able to match the form of the problem to something that it's in the back, right? And then just collect the constants and things. Generally this is not on the test because for the test I can't give you computer, I can't give you table of integrals. So we don't really do anything with 8.7. I'm going to take about 5 minutes and come back with 8.8, which is numerical integration. We're going to learn 3 formulas here and call it a night. So let's say at 7:10, we'll restart the stream at 7:10 with 8.8 numerical integration. Bye.